Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and if my calculations are correct, this will be the last video for 2022. It's been a really good year here on the channel. I appreciate all the new subscribers, all the views, the comments, the thumbs up, everything you've done to help support this channel. I really appreciate it. In this video today, we're going to do a little project that I've been wanting to do ever since I got my surface grinder, but I just never took the time long enough to do it. We're going to add a DRO to the y-axis. Now the y-axis on a surface grinder is the axis going up and down. Z-axis is the one that goes in line with the spindle. But we're going to add a DRO to that, and what we're going to use is one of these eye gauging DROs. I've got a pretty good supply of these. My first exposure to them was with my little X2 mini mill. I put them on that, and it's actually still on that mill. I then put a set of these on my Precision Matthews 727 desktop mill, and again I put a set of them on my Precision Matthews 1127 lathe, and they work pretty good. But over time, having these on the Precision Matthews mill and lathe, these don't fare too well if coolant gets on them. And I use a flood coolant system on both the lathe and the mill, and if they ever get wet, they have to dry out for a long time. And so I replace these with glass scales and full-size DROs on the mill and the lathe on a Precision Matthews one. And by doing that, I wound up with a pretty good collection of various scales and readers and so forth. So we're going to take this one, let's see, I'm not even sure what length this one is. This is a 16-inch scale. Let's look over on the DRO or on the surface grinder, and I'll show you how we're going to mount this. Now stick with me, because I realize not a lot of you will have a lot of interest in mounting a DRO on a surface grinder. But the way I'm going to make the mount for that, hopefully you'll find interesting. Okay, again, what we're wanting to measure on the surface grinder is the movement of this spindle right here. And that, again, is called the y-axis on a surface grinder. What we're going to do is suspend this out here in this area, somewhere about in this area. And then we're going to make a bracket to go on the spindle housing itself right here. And from that bracket, there'll be an arm that reaches over to this reader. These, of course, will be permanently mounted, but the reader will be able to slide up and down with the spindle. To make that bracket to go on there, I've got a piece of 1-inch thick aluminum, and no, I didn't buy this just for this purpose. I've got right much of this that came from an old manufacturing plant, used to be here in the area. But we're going to make that such that it clamps on to this spindle. We're going to put this in the 4-jaw chuck and bore out our hole, which I believe I measured that as being 3.64 inches. So we'll bore a hole that size in this. We'll drill for a couple clamp bolts, and then we'll split it through the middle. And that's the part I hope you'll find interesting in this video. Once we get that done, I'm kind of doing this, playing it by ear, but I'll come back over here and work out a mount, some way to mount this over here and attach it to this bracket. Now I do use flood coolant on my uh, surface grinder as well as on the mill and the lathe. And with this scale being back here, I'll be able to put somewhat of a protective cover, splash guard for it, if you will, to keep any coolant from flashing back. The coolant is down in this area. So I'm going to get the 4-jaw chuck on the lathe now, get set up, and bring you right back. Okay, before we turn to the lathe, let's go ahead and lay aside the center on here, and we'll do that by going corner to corner. All right, and as I said, that's 3.64 is the width, or is the diameter of our spindle. Half of that is 1.82. I'm going to set my calipers to that and just give myself a little marks on the paper there, spread marks, and then I'll use my dividers. I use those marks to set the dividers. And I'm just going to draw that out. Not sure with the reflection you can see it, but what I've got is the outline of the circle we want to make. And that'll just give me a guide to go by on the lathe. So now we're ready to turn over to the lathe and get this set up for boring. Alright, I've got the 4-jaw chuck on the machine now, and I've got the jaws turned around and got them set pretty close. Now to get this on center, we'll take our dead center and put that point in, bring our tailstock up with the live center in it, put a little pressure on, and I'm sure you can see the dead center is wobbling there. So we'll take our indicator. Alright, and let's see, I got to be sure we're touching all the way around. That's the high spot right there, so I need to move and need to tighten the high spots. Okay, I realize there's a lot of glare on the indicator here, but hopefully you can see the needle. And again, looking for the high spot. That's within 3/1000. About 1.5 thousandths. Let's see. Man, that got really tight. And that just made it worse. I don't do a lot with the 4-jaw chuck very much. First time I've had it on probably in 6 to 8 months. All right, I'm going to leave that alone. That's within 1 thousandths right there. So now I'm going to put a drill in to get our starter hole, and then we'll start the bore. All right, we're going to start with a 7/16 hole. Now we'll move up to a 1-inch hole, which is the largest metal bit I've got. We'll slow our RPM down. Now for some time I've had this 3/8 inch boring bar, and this 1/2 inch. 3/8 and a 1/2 inch. If you recall, if you've been following the channel very long, a couple years ago I made these blocks right here to hold those 2 boring bars. I just recently picked up another boring bar. This one is a 5/8, considerably stouter than the other 2. And this will be my first time actually using it. I ran it through a piece just cleaning up the inside of a welded pipe. But to actually bore a hole, this I think is going to be the first time. All right, let's be sure I got clearance. We got plenty of clearance here. But I'm going to go ahead and put my carriage stop in place just as a sanity check. All right, that's got that point clearing on the back side. Let's try 20, 40, 60. Let's try 80 thousandths. That'll be 40 on each side. We can bring our RPM back up a little bit. That's about 500 there. All right, that's cutting pretty good. I need to watch this tip right here and be sure it doesn't get hot and build up on that. I think a little bit of WD-40. Now, as you recall from the workbench, I've got my witness mark out here that'll show me where I'm getting close. So you guys grab you a cold snack and sit back, and I'll bring you back when we get pretty close to the end. Okay, I think we're getting close now, so let's see if we can get a little measurement here with the snap gauges. That measures 3.550. And we said 3.640. I'm going to go 3.7. We definitely don't want it too small, but it'd be okay if it's a little bit big. So that's 150 thousandths left to take. And we'll take 60 thousandths at each time. All right, now we'll take our final 30 thousandths. Very nice finish. While I got it right here in the mill or in the lathe, I can go ahead and deburr this outer edge. I'm not going to try sticking my hand in there to get that inside edge. I'll deburr it after we get it out. You know, I may be able to turn it around enough right here. Won't have to worry about it being centered in. And It'll probably have a little wobble, but it'll be fine to deburr it. All right, now I think it's time to lay out for the center split, go over to the mill, and before we split it, we'll drill and tap for our clamping bolts. All right, I got a mark on here where we'll eventually slit this in two. But before we do that, we want to put our clamping bolts in. And I've got those laid out through the center and 1/2 inch in on each end. So I'm going to line this up with the edge of the jaw so that we can repeat that. The clearance drill for the 1/4-20 we're going to use will reach deep enough to get to the halfway mark. The tap drill I have for 1/4-20 is actually a stubby one, so it would never reach down in the drill. But we're going to just go beyond halfway, which in this case will just be clearing the flutes on here. But with this lined up, we'll set the DRO at this mark and at this mark over here. Then after we slit it, we should be able to come right back to those same positions to drill and tap for the 1/4-20. So let's get this lined up now. So I'm going to zero out the X at this mark. And we'll zero out the Y right there. Now the Y should not change for any of this. Now our piece is 5.855 wide. So if we're going to lose a 1/2 inch here and a 1/2 inch there, we need to come to 4.855. And that looks dead on our mark that we made. This is probably going to pretty much max out the height for this mill. What I'm going to do is when the edge of the bevel on the drill bit is even with the top, I'll zero out the Z-axis DRO. Then we need to come down 2.928, which is half the block. All right, I'm going to zero out right there. All right, that shows the depth now. I'll recheck that, and that is like the drill bit might have slipped in the chuck just a little bit, so I'll re-zero out right there. And again, just in case that didn't go deep enough to score what will be the bottom half, I've got my DRO measurements. So now let's pull back over here. And we'll do the same thing. All right, now we need to countersink this. We're using the socket head cap screws. Of course, this one's not quite long enough. I've got some more. It's supposed to have been in this morning's mail, but looks like it'll be tomorrow before I get here. But we need to countersink this 250 thousandths deep. Going to actually go about 300 thousandths just to be sure I've got, don't have the head proud at all. So we'll zero out right there. All right, I think we're ready to get the chuck out and get the slitting arbor and slitting saw. Okay, again, this is another one of those projects that if you've been with the channel for a couple years, you saw me make this long reach arbor for the slitting saw. So I'm going to cut probably about 750. I don't want to change the readings on my DRO at all because I'll need those for the drilling and tapping. And that looks good on the height. I'm just trying to be sure I'm at least over halfway. Tell you what, I think I'll slow it down just a little bit. 600 down to, let's try 320. All right, I'm going to stop for a minute and change this blade out. That blade is just too dull, even for aluminum. Okay, folks, these slitting saws that I've got, blades are just not going to cut it. They're just simply too dull. It's time to replace them with some new ones. So what I'm going to do is take this piece over to the bandsaw right quick, and I'll bandsaw the rest of this in two, and then we'll put them back in there and dress them up just a little bit. Okay, the reason I didn't go to the bandsaw in the beginning was that I wanted this extra gap in here that a slitting saw blade would give me. That gives some clamping space on here. So what we're going to do is, I got the two pieces set in here now. We're going to take the end mill and pretty much clean this up down to where the slitting saw made its mark. And dressing this up is pretty much going to do away with the witness marks I made drilling all the way through, but that's why we took precautions and set the DRO up and lined up with the edge of our milling vise. All right, I'm happy with that. We'll get set back up now to drill and tap for the 1/4-20. All right, I got them deburred. We're going to take this bottom piece, and let me show you right quickly what I've done. I'm being as precise with this as I know how to be, but obviously I can tell from the die cam on here, this is the way the two pieces started. So I put a couple little witness marks on the end down here, just a single punch on this one and a single punch on that. So once I get these cleaned up and the die cam is off of there, I know I'm lining them up the same every time. That way, if I am off any at all, it should be, they should match up fine by matching these witness marks. So we need to take our DRO back to 0 on both the X and Y axis. And that looks right on the money. So let's get us a starter drill. And my mark down here is gone, but I believe that was, okay, that's 4.855. This, of course, is our tap drill for quarter 20. Alrighty, we've got the, I think we're pretty much done with the clamp. Clamp mount goes on the spindle. We'll turn our attention now to actually mounting the DRO scale. Okay, this video is running a whole lot longer than I thought it would, so I didn't try to show you drilling and tapping and fabricating all these mounting pieces. But as I said at the beginning of this video, the primary purpose of the video is not so much the mounting of the DRO, which some of you may find interest in. Chances are most of the interest will be in the boring and making of this clamp to go around the spindle. But what I did was take this piece of 1.5 by 1/8 inch flat bar aluminum and mounted it using the existing screw holes that are holding this cover onto the surface grinder. Once I did that, I mounted the DRO to this strip out here. As I said earlier, I was going to need to suspend that somewhere out in this area. Before mounting that on there, I made this little Z bracket though. Bent that on the pan box and pan brake. Drilled and tapped the block here for a 3mm. The back of this was already 3mm. Simply run my cord around over here. The display is magnetic, so it stays can stay in this area. I do have the full 9.5 inches from the top. Of course, I'd have to move the display out of the way. But that comes up right flush with the top up here, and the bottom still had, all right, that's pretty much bottomed out on the mag vise now. As the wheel wears, I still got another 3 inches there, which I never wear the wheel down that much. In any case, it's mounted. The verdict is still not in on just how accurate this eye gauging is going to be over here. I'll test it against an indicator on here and against the dials on here. But even if I do replace the DRO, this mount will still be required to connect the DRO to the spindle. So I hope you got a little bit of enjoyment out of this, a little bit of pleasure seeing this large hole milled out or bored out on the lathe. I posted a picture of it on Facebook. A couple people suggested I could have trepanned that around, which I don't know whether I could grind a bit that would go a full inch deep, trepanning 3 3/4. And then a couple more suggested that I should have used an annular cutting bit. Here's what I found when I did a research on 3 3/4 inch annular cutting bit. Almost $1,700. I believe I'll stick with making a mess with the chips. Again, hope you guys enjoyed this. Got a little bit out of it. I'll see you on the next video.